There you go.
All right. Hello, everybody. My name is Kyle. Chief Hardware Officer for the ACM chapter. Joshua can't be here, and I think Sam also can't be here tonight. So they've asked me to step in and kind of give an introduction. Tonight, we're going to be having Joey Kilgore give a rundown of the fundamentals of Git and source control. So without any more uh, delay, here's Joey Kilgore. Joey?
Hi. Hi. Okay. Um, so I was trying to figure out like how to make this productive for everybody because some people have never heard of Git or what source control is. Some people have heard of it, never used it. Some people have used it and have used it professionally. So I tried to see if I can bridge all the gaps and give everybody a little something to nibble on. So I figure we might as well just get right into it. What am I about to bore you guys with? Um, Hopefully it's not too boring. But Git essentially is it's a way to keep track of versions of your code. Um, it's mainly used for code. Theoretically, you can use it for other things, but it's really just used for code, and that's what we're going to talk about. So it tracks changes of files, and it records them and lets you revert to specific versions. It allows multiple people to work at the same time. So that's pretty useful to be able to have a bunch of people working on the same thing at the same time, especially as programmers. The thing to kind of think about is, a whole programming team, might be like 8 people. And if you're all working on 5 files, well, then obviously there's going to be some programmers that are changing the same file as another one. And how do we deal with that? And what happens when that one programmer who we all know doesn't really know how to code, and we're not really sure how he got a job here? What happens when that guy changes something and it breaks, and we need to undo his changes? Or if you want to get more, maybe there's a malicious intent with it. How do we go back to old versions of code prior to somebody purposefully going in and breaking stuff? And pretty much the best way to explain like really how this is going to work is to look at a bunch of graphs with a bunch of little dots on them. So this is one of our hackathon projects. Specifically, this is Olga, our open source language guided assistant. I think we actually have a video on this one. But the point is that each little dot here represents a change to the source code. So if I click on any of these dots, it'll kind of bring up the change. And so each change, it'll say what line was removed, what lines were added, the name of the commit. I'm going to refer to changes as commits because that's essentially when you do a bunch of changes and you save those changes in the Git source control, those changes are going to be called a commit, and hopefully I'll use it enough times that it'll just kind of make sense by the end. But so we can see from this commit, I updated the README, and the README is just a file that has some documentation in it. And I can go through on any of these little dots here and see the changes. So if I click on, what's this one? Basic Hello World Works. So let's see, Basic Hello World Works. We changed this thing, we changed that thing, we changed that thing. Here's a couple co-authors, so we know who made these changes. That's another important thing. And then I can go through the entire source code and see what lines were deleted, what lines were added. So you can see how powerful this could be, especially if instead of having 5 programmers, you have, what is it? I think Highland Software has about 300 programmers working on, tens of thousands of files across that. How do you keep track of all that? Well, we need to keep track of all the changes so that we can go back to any version. So from there, I'll kind of explain why there's a bunch of different colored lines as we go, and I'll probably come back to this. So hopefully that made sense of like what a commit is. It's just a series of changes, and this allows us to go back to any version and because this is just a sequence of changes, you can just easily undo the sequence to get back to where you want to go, which is extremely useful. Not to mention, this is stored remotely, so that when my computer crashes, I just download the most recent version and it all is on my machine, which is really nice for projects. Okay, so hopefully now you're no longer bored about this. May I grabbed your attention? Let's see how long that lasts. I think it's important to kind of look at the history of where this came from, and I had known. So if you know who Linus Torvalds is, he is the creator of the Linux operating system. Specifically, it's the Linux kernel. But the nuances on that aren't that important for this. But so he was working on Linux, and that was an open source project, and they had a bunch of people working on it. And obviously, when you have big projects, you need to keep track of changes. And they were using BitKeeper, which at the time was free for the community. So if you were doing like open source projects, it was free. But then BitKeeper decided, no, actually, we're going to change that and we're going to make it not free. And Torvalds was like, no, I'm not paying for that. And so he spent 2 weeks to recreate something to do what he needed, and then made it open source. And from that, we have Git. And so really, this entire thing was just kind of just a workaround for his main project, which that being Linux. So that's kind of entertaining. From there, this is from the man page, man standing for manual. It is the stupid content tracker. And since 2005, pretty much after Torvalds had done the initial work, it's been maintained by this little Gitster right here. Which, yeah, many programmers always have entertaining names and stuff. But if you're looking at how important this is and how much you should care about it, Git in 2018 was used by 87, or at least was known by and used by in projects by 87% of developers. So hopefully that's a significant enough number of people that you can see how important it is. I think just about everyone I know has used Git on their co-ops if they were writing code. Jared, don't you guys use Git at Ridge? Oh, I saw him unmute, but he didn't say anything. I'm sad. That's okay. I'm sure he probably does. Oh, he posted in the chat. Yes, sir. Yeet. So yeah, so important. Now this is where I might start to scare people. Let's hope it's not too scary. It's kind of cool though. So you have a repository, which for all intents and purposes is just the folder where all your code for your project is. And you're going to have a remote version of that, and you're going to have a local version of that. And then there's a whole bunch of commands that let you like set different versions and grab different versions and go back and forth between versions. And so I might come back to this because maybe it'll make more sense as we kind of go through the commands. But the main thing you're going to be doing is kind of down here, how I was talking about commits. The main thing you're going to do is you're going to set up a commit because you're working on files. You're going to commit some files, which is going to create a change that'll be on your branch. And then you'll push that to the remote repository because usually you're storing your code remotely as well. And from there, you know, you can keep making changes. You can keep pushing those changes to the remote repository. And then let's say you have like 50 developers on this. They're all pushing the remote repository. And, you know, I want some of their changes that they've made. I can then pull their code down from the remote repository. And so it's a lot of committing and pushing and pulling. And It's a kind of a nice circular uh, change of code, or circular commands where you're kind of going in a cyclic fashion. So let's dive into a couple of these commands to see how they work, and then let's actually try and use some of them. Let's get a little hands-on so that you're not totally lost with this. So the first commands, which are setting up the repo, you have your git init and git clone. So git init would set up your just a local repository, whereas git clone would take a remote repository, and then it's kind of like an initial poll where it's pulling everything from the remote repository and cloning it onto your machine. And you can kind of see that here. But both of these are good, but personally what I've found is it's just easier to create a remote repository and clone it, because you're pretty much always going to want a remote backup of your code when you're working on a project. And GitHub allows you to make free repositories, so it's not like there's any harm in creating it remotely first and cloning, whereas sometimes it's annoying to set up your local repository and figure out how to connect it to the remote one. That's the only thing that can be a little bit annoying if you go from a remote repository or the other way around. So that's what I strongly recommend, and we'll step through it, so don't worry if you're a little lost by the setup is kind of a weird thing. It's more the steps in the middle that are important to kind of figure out at first. So the big thing here, which we need to focus on, is how do we make a commit? So let's say you change some files on your machine. As you saw, like some of those previous commits I showed, you know, they had a couple changes. What I like to do is I'll add the file, and then I'll make a commit with all the files. So if you saw on this little diagram, so I have my working files, I change a couple of them, and I add them to what's called the stage, or staging area. And so, you know, maybe I got some random file that I've included like some passwords on and hard-coded some stuff that I really don't want anybody else to ever see. I won't add those to the stage, which means they won't be added to the commit. So I can keep some files changed on my machine that'll never go anywhere else, and that's fine. I just have to make sure I don't commit them, and to make sure I don't commit them, I just have to make sure I don't add them. Some people like to do the commit-a, which is commit all change files, or commit all changes. That can be dangerous if you made a bunch of changes that you forgot about, and then you just committed them, and now you have to figure out what to do. And we can talk a little bit about that. But so personally, I like to add the files that I've changed, because I kind of figure in my head what files I've changed, and I'm like, oh yeah, I should probably save those in some way. And so I do that, and then I commit, and I leave a nice little message that says, hey, this is what I changed, here's a couple little notes about it. That really makes it powerful, because if I want to go back to a version, I kind of want to know which version I want to go back to, and the text of the commit, like the message, kind of leaves you like a nice little trail of breadcrumbs to figure out where you want to go to. So that's what I recommend. The -a is commit all, but it's powerful but dangerous. So like a lot of things on the command line, there's a lot of power, but you can go down the wrong path very quickly. The -m or the M flag lets you put the message right there. So that's commits. Are there any questions so far? Because this is kind of a key point to kind of stop at and take questions. Maybe you're completely lost and you thought none of this made sense. That's fair. I do not appear to hear anything, but that's okay.
It seems good so far.
Awesome. I see a Mr. Jonathan Bender is typing. I'm sure it will be filled with puns. Awesome. well, I'm not going to bore you too much with commands, but there are a few more we should probably go through. Branching. So this is, we can take some time to talk a little bit about what the heck all these extra lines were. So each line here represents what's called a branch. And so obviously, like if I'm making a set of changes, I kind of want my changes to be on some separate set of code from, let's say, Jared's making changes at the same time. In this case, in this project, it's easy because Jared actually was making changes at the same time I was making changes. And so, obviously the changes, if I'm working on a feature here, which I think I was working on, so I was working on the front end here and Jared was working on the back end. Obviously, our stuff really doesn't need each other, so I don't always need to be grabbing Jared's changes and Jared doesn't need to be grabbing mine. But at the end, at some point, we got to combine them back together. And that's what branches are for. What they allow is, so right here, I kind of take my own branch and Jared takes his own branch. We work separately. And then what we do is we come back and we merge them back into master. And where this black line at the top, the master branch, that's the key branch. That's the main one that when we're finalizing things, that's where they go. So branching is something that takes a while to get. Some people, when they work on projects, they'll just keep making changes to the master branch, and that can be okay. But if you're having multiple people work on things, having branches allows you to separate it cleanly, and then I don't ever have to worry about Jared's stuff while I'm working on my stuff. And the other bonus is I can push my code remotely and it'll save it on a separate branch there as well. So remotely, Jared could still see where my stuff is. I can still see where his stuff is if I need it, but I don't have to see it if I don't want to see it. And that's pretty powerful. So that's the overview of branches and why they're so effective. Sometimes, in this case, we made it each developer got a branch. Sometimes it might just be each feature gets a branch, and there's a whole kind of way of thinking about how should I do branches and how do I make it as clean as possible. And I might touch on that a little at the end, but it's not terribly important. Just knowing that each branch allows people to work separately but together, which is really powerful. So to do that, the branching lets you, so git branch lets you select which branch you're on, and you can do -B, or sorry, -D to delete the branch. Git checkout allows you to actually switch to that branch. So if I'm on master, I can create the branch using the branch command, but then I have to check out that branch to actually switch to it. And we'll go over that a little bit in a second. So you can check out to that branch. You can also check out and create the branch at the same time with this tag. And then from there you can merge the branch, but I'll talk a little bit about why I usually don't do it from the command line. Merges takes one branch and put it into your own, but likely you won't do this. Instead, you'll make pull requests, which we can talk about in a little bit. Okay, I think there's one this is the last slide about commands, and then we can actually do something fun. So commands, so this is for synchronizing between the remote repository and your local repository. So fetch will grab the remote changes and download them, but you have to, and then you can merge those branches into your branch. That's a little confusing, so a lot of the time what people just do is pull, which is pull just fetches the changes and puts them on your current working files, which is usually just what you want. Sometimes there's errors with that, but this is usually what people do. And then, so I'll pull when I want other people's code, and I'll push to let other people have my code. So I push it to the remote repository. Okay, that was a lot of spewing knowledge. So I think we should do something a bit more interactive. So let me copy and paste this link. so that everybody can pull this up if you feel like it. Visualizing Git is one of my, it's a really nice website and it's a really good tool. So let me refresh the page so that I have a clean working space. Okay, hopefully it's not too small for you to read. I think I can zoom in a little bit. And I'll give you a chance if you want to open it up, or if you don't want to open it up and you just want to watch, that's fine too. But the first thing we can do, once we get it open, we can make a git commit. And there it is. That's the whole thing. That's our commits. That's all we do. We can keep doing, we could do this all day where we just do git commit. Normally then you'd want to add like a, I don't actually know if you can add a message in this particular one. Oh, you can. There you go. So this one has like a nice little message with it. I did that with -m. Usually if you do a git commit on like the command line, it brings up a text editor for you to write a message, but that's not super important. What else? So we can commit, might as well. You can practice committing. It's always important. It's always good to make commits pretty often. Because you don't want to, that's one of the problems, you know, you don't want to be keeping track of versions but only make a version every new year when you work on stuff. That kind of defeats the purpose. The point is that you're making incremental changes so that you can always go back when your incremental change fails you. It's kind of like just leaving breadcrumbs for when everything burns to the ground, and then you can go back and figure out where everything went wrong. So okay, now it's time to get a little spicy. We can create a branch with git branch. I'm gonna call it dev1. And now we can see we have master and we have dev1. And then you're gonna wonder, okay, what the heck is this head thing? We haven't talked about it. So the head is going to help us keep track of exactly where we are. So you'll see right here, the head says we're at master, which means we can look at this and say, oh, we're on the master branch. The other way you can check that is if you just do git branch, it'll list out all the branches that you have, and it puts a little star or an asterisk for me. It'll color the one that you're on. It's like, okay. So if I do a commit right now, what branch do you think it's going to add a commit to? I'll open it to anybody who wants to answer that. If I commit right now, it's either going to go to the master or the dev1 branch. Which branch do you think it'll go to?
The master.
Yeah, I think I heard master, so let's see. Yes, beautiful. Good stuff. So, that's cool, but
The
what?
master branch?
Yes. Good job. So, what if I wanted to commit to the dev1 branch? Well, that means first we have to switch to it. And to switch, we need to git checkout, and then we can type in the name of the branch. And you have to be precise on how you spell it. And you can see when I did the git checkout dev1, our head is now at the dev1 branch. And so if I start doing git commits on this branch, now we have two branches, or maybe you can think about it as two people working, and they're using different code, but they can still kind of see each other if they need to. So I can make a couple more, I can make another commit, and then I can switch back to the master, which is git checkout master. So I can see that, git checkout master. I can see my head moved over, and so I can git commit there. And I said, okay, the two of us have done our development. It's time to merge them back together. So now that I'm on master, that's the key. So if you're on your dev1 branch, you got to use the git checkout master. And then you can switch back over to master. And then we can do git merge dev1. And that put them back together. And specifically, it put them back together such that when they're put back together, they're on the master branch.
So this works together as well as it does, presumably because Git only logs changes rather than every single file in the directory at the time of commit, correct?
Yeah, and that's important to think about, because if we saved every file, every commit, this would be horribly inefficient.
But because it's just a large pile of insertions, it's much more efficient, and even someone with a toaster or a computer could do it in a timely fashion.
Exactly. Yep.
I have a question.
Yeah.
Is this a little similar to what like Google Docs can do?
Yeah.
Like it saves changes without creating a new file?
Yes. That is, as far as I can understand, it's actually extremely similar in that way. The only difference being, normally you don't create two versions of the document and then combine them together. But yeah, when you're on Google Docs, you can look at the history and you can see it's this line of changes that have, oh, you changed these lines and that's your name next to it, and this person changed this line and that's their name next to it. That's an excellent analogy.
Even redacted stuff, like say I go into a Google Doc and I type butt fart and then I erase butt fart. Someone would still be able to look inside it and see that I typed it and then make fun of me.
Yes. Yes, they can. Awesome. So the last thing that's kind of important here is, well, okay, I took the code that was on dev1 and I put it on the master branch, so now the master branch has everything. So I don't really need the dev1 branch anymore. I guess I should get rid of it. And to get rid of it, we can do git branch -d and then the name of the branch. And now it is removed. And there it is. We've made changes. We had two people making changes in tandem. We combine them together and we're back to just a single master branch where we can just git commit. I'm stupid. And now we can just go back to making changes, and when we need to, we can split it as needed and then combine them when they're done. So very powerful. The last thing, which is also useful, let's if you can and if you're open on this, click on the free explore with remote on the drop down, and it'll ask you to erase things and you'll just click OK. And so this is going to give us a setup where we have a local repository and we have a remote repository. And so when we make changes here, we just also have to make sure we save them remotely, or at the origin, as it's kind of termed. So let's make a couple git commits, and you can see how obviously locally in the local repository we have all the changes, but they're not saved at the origin. So you can think about the origin as this GitHub repo that's online. Because it's online, everybody can kind of look at it, and it's the origin. But if I have a copy of this repository on my machine, that correlates to the local repository. So, okay, so I've made changes. So I should git push those changes. And you'll see how the origin master, which is kind of it's the clone of the remote repository. It's keeping track a little bit of where the origin last was as far as it remembers. And so that moved up, and then we also saw that those changes were also pushed to the origin or the remote repository. And from there, if there were changes remotely, you can do a git pull, and you can see it fetched 0 commits, and then it said my master was already up to date, which it was, because there were no additional changes. So obviously from here you can start doing things where you branch. So I'm going to do the fancy checkout, which you add the -b and you can create and switch to the branch in one, and then commit. And then from here I could do a git push, and it'll also push the branch as well. So you can do stuff like that. So it'll also keep track of the branches in the remote repository as well. So hopefully that was, while it was quick and fast, it gave you the brief overview, which should be enough to at least make sure you know how to make changes and save them appropriately.
So what was the difference between the local repository and the origin? Is the origin what's up in the in the servers, like the cloud?
Yeah. Yep. Yeah, the remote is essentially what's, I mean, it's quite literally the remote version of the code. You know, it's stored somewhere, wherever.
No, and so the local repository would probably be like in your computer, right? Or is it?
Yep, exactly.
Is that right? Okay, gotcha. Where would they be stored? Like, what server is running this? Like, who would be like funding the server?
Yeah.
To keep going.
So currently, Microsoft actually owns GitHub. So that's one. This is a pretty common way, and because of that, you know, it's easy to get space, and Microsoft makes it pretty free and open. In fact, there's actually additional benefits for students. If you make a student GitHub account, you can get a bunch of extras, which are really nice. I think one of them, I think they actually have made, you can have an unlimited number of private repositories, which is nice because my school projects I can back up on GitHub and nobody sees them because they're private. But obviously there's other options. I don't know if anybody in this chat has used GitLab before, but I think there's ways you can set up your own server as a remote and then set it up so that it's the origin, and then you can push and pull from your own server as your backup. So yeah, there's enterprise versions of GitHub, but some enterprise companies are just like, well, we already have our own server, so we might as well just save the code ourselves, and they'll use GitLab or something like that. So
gotcha.
Yeah. Any other questions? That was a good one. That was really good. Okay. So everything I kind of went over was about the command line. And so I have to say this because I use a graphical user interface for the majority of my Git source control. And what I mainly use is I use what's called GitHub Desktop. So it's probably a bit blurry. Let me pull up a good repository. This one has some changes to it. So this is like a nice graphical user interface. It's probably pretty blurry because it's super tiny font. But on the left here, it shows a list of every file that's changed, and I can check which ones I want to include in the commit. It shows me.
Joey,
yeah.
Change your window.
What do you mean?
I think you're just showing your browser.
Oh, really? Huh.
Yeah. I can see that stuff.
Weird. I thought I set it to do. Let me stop it for a sec and share screen. And share screen, which should be monitor 1. Go live. How about that? Does that work?
Yeah, that's good.
Awesome. So yeah, on the left here, I can see what things have changed. I can see how they've changed. I can create the nice title for our message. I can give a description. I can add co-authors. I can switch branches. I can pull and fetch all I want. I can change what repository I'm in. I can create new branches. I can do all that stuff we just discussed from a nice GUI and not have to remember all those commands. And honestly, that's what I kind of do most of the time. If I don't have a particular reason or need to pull up the command line, sometimes it's just easier for me to check a couple boxes, type in some stuff, and click a button, and it's saved remotely. And that's pretty nice. When I worked at Highland, it was like built into Visual Studio. I think there's actually some stuff that's built into Visual Studio Code. You can have it right there. Visual Studio Community, we definitely had it, and you could just click right there and it would do everything for you. So I would be kind of dishonest to say you're going to do it from the command line. That's not to say a lot of people don't do it from the command line. Plenty of people use the command line, and I'm going to try and give a case for why it's useful. But in all honesty, if I'm really talking about how you're going to use it, a lot of the time you're just going to use a GUI because it's easier, don't have to remember it. And for that, I recommend GitHub Desktop, especially if you're using GitHub for hosting your repositories. There's plenty of other ones. So how about I try and make one here? Why don't I, if you guys have any questions about the GUI, now is probably a good time since we just talked about it while the chat's being filled with Git puns. Hopefully it's most of them are pretty self-explanatory. Well, awesome. Then I'm going to try and make a case for being a power user, the case for a command line. So if the graphical user interface does pretty much everything you need, and why would I ever use the command line? And the key thing, which is pretty much true about everything when you're using the command line, is the GUI doesn't give you full control of Git, the command line will. So is there a case when you need to use the command line? So I actually did have a case. It was actually only like 2 weeks ago, and that was part of why I wanted to do this talk. Was I needed to remove some data from a repository, and not just some data, it was like 0.5 gig of CSV files that I had, which meant it took like a solid couple minutes to download, and that's kind of a lot of space if you're on like a smaller machine or something. And considering the rest of the repository was only like 100 megabytes, this took up like literally 80% of the download of the repository. So, and it wasn't really that important either. So the question was, how should I get rid of this? So does anybody want to tell me why I shouldn't just delete the file and commit? This one kind of requires a little bit of knowledge of thinking outside the box. Why would just deleting these 0.5 gig files and committing it be a bad idea?
It clogs up the commit history of the entire project. Anything that branches off of it will have to deal with that large pile of changes.
Yes, that's the key right there. Since we delete it, it's now saved as a change. So no, I can't just delete the file and move on, because that's just going to push it to the Git history. And so now you're still going to have to download it, because every time you clone the repository, you download the entire Git commit history. What do I have to do? This would only move, so it moves all the data to the Git commit history. That doesn't fix the problem. So I needed to remove the file from the entire Git history, which is something you'll probably never have to do. But because I needed to do this, or at least in my opinion I needed to do it, I also then needed to use the command line. because the GUI would never give me the control I need, because who in their right mind would want to remove a file from the history? That's literally the antithesis of the entire project, is to remove something from the history. But I needed to do it anyways. And the command line will let you do it, which is usually pretty true. So here's how you do it. Don't ever do it. What this says, so it goes through the branch with force. It filters out looking for a git removes, so it removes the caching or the changes of this folder, and then it does it recursively, so it looks through this folder and every folder within it and removes all of that. It removes every tag, and then I force push all of that change and removed all of that, and I push it to the remote repository. This is literally impossible as far as I know to use the GUI to do it, and I would have only been able to do it from the command line. You should never do this, but
Question.
sometimes you need to. Yeah.
Why do you use the backtick on line, or sorry, the tick on line 2?
The ticks allow me to continue the line.
No, not the slash, is the tick. Is it an apostrophe, or is the thing that's like the unshifted tilde?
Oh, these. I think there actually probably should be one more, because I think this is a command.
Yeah, because it was unclosed, and I was a bit confused for a moment.
Yeah, I'm pretty sure. Yeah, I think there's supposed to just be a tick in there, so it recursively goes through and does all this.
So that slash isn't actually there as part of the command. It's just that you're separating them by line, saying they're all part of one command.
Yeah. This is all one big command right here. And I just copy and pasted it from the internet, which is entertaining.
Very safe.
Yeah, this is also like my work repository, but luckily I knew what was going on. So, but this git push with force all is very dangerous, and hopefully a following joke. This takes all your changes and forces them onto whatever the remote repository was, and that means there's always chances that somebody's push changes that are going to interfere with yours. Like, what if you both change the same line of code? You should just when you're working on that, it'll give you errors, and from there you can figure out, oh, their change is more important than mine, or their change is better than mine, so let me not push this particular change. And it'll warn you about it. You'll say, okay, let's fix it. You'll edit it, and then you push it, and everything's clean. But forcing it, I believe it just forces all your stuff on top of it, which could break a lot of things. So, this is one thing. Other things as a reason to use the command line. If you know all the commands, sometimes it is quicker than going over to the GUI and trying to click on stuff. I'm also a fan of the command line because sometimes I just don't want to have to bother with going through menus. Okay, that's probably one of the biggest pet peeves of using a GUI, is you end up having to go through a bunch of menus, and it's like, well, I could just type it in all in one command and never leave the keyboard. And a lot of people, including myself, just really like the command line interface. It's just easier, it doesn't get in my way, and it does exactly what I tell it to, which I can't say about many GUIs.
And considering that our field is kind of what we call a very, very high risk for things like arthritis and RSI, or sorry, repetitive strain injury, just in general.
True.
It's kind of a point of concern. Some people think, oh, I should get good at these sorts of power usery things because it'll minimize the amount of time I spend alternating between keyboard and mouse.
Yeah, that's definitely true.
So to make things really brief, when you alternate between keyboard and mouse, you have to rotate your wrist in a way that's not exactly conventional.
Yeah. Not to mention, it kind of gets boring to go back and forth between keyboard and mouse and back and forth every 3 seconds while you're in a GUI, when I can just stay on the keyboard the whole time in a command line interface. So hopefully I made a case for using the command line. Some of you might never use it. Most of you will probably use it some of the time for specific things. But it's useful. and it's really useful, especially if you want to work on projects with other people. Just to know Git, and understanding the commands are kind of important, because then the GUI doesn't make any sense if you don't know what the commands are. So maybe knowing how it works is really all that you're going to need to get from the command line, and sometimes that's good enough. I thought I should include a couple further just random things that you can dive into if you find you enjoy this stuff. Git ignore files allow you to ignore certain files from the history. So if I'm, sometimes it's like a particular type of file. So in Python, there's like Python cache files that are generated sometimes, and usually that's just random Python bytecode, and it's not particularly useful for anybody ever, and it's recreated every time you run it, so it's really not useful. So sometimes it's useful to just ignore that altogether. Pull requests are nice. That's for, instead of merging from the command line, sometimes you want to merge on the remote repository first, and pull requests lets you do that. And actually, I can pull up one so you can kind of get an idea. So from this project, where's a good one? So this is a little one. So it's a branch, and we're gonna merge it in. So we have the list of commits that are connected to it. So, here's the commit, and then from there, somebody can approve the changes and then merge it, and from there they can delete the branch. So it's like merging, but now somebody else is making sure this is okay. And this is extremely common in developer environments. When you're working with other developers on like an actual team professionally, you always have people that are kind of working together and checking each other's work, because you don't just want one person to make a dumb mistake and then commit it and merge it into the master branch, and now your master set of code has a dumb commit in it. You don't want that. So we work together because we're all going to make a dumb mistake at some point, and it's nice to have us collectively work together to try and eliminate as many of those as possible.
Something I'd like to vouch for briefly.
Yeah.
Pair programming. If you ever have the chance to do so for a hackathon, try to make use of the remote powers that Visual Studio and Visual Studio Code have the ability to use, as that can also reduce out mistakes. Say that one of you is extremely sleep deprived or is a little distracted. Well, the other one can point out, hey, that's a really bad mistake you're making. You shouldn't do that.
Yeah, I think, this commit, I think particularly, we kind of did that. We kind of worked together, and that's one of the things. When you work together, then you can, if you know what you're doing, you can keep track of who worked on it together. And so that's another thing. But yeah, pair programming, extremely fun. We definitely need another hackathon soon, so we can do that kind of stuff. Other random things, pull requests, branching strategies. I mentioned that a little bit before, but maybe we have our master branch, we have a developers branch, and then we kind of have features that go off of that, and then we merge the features into a developer branch, and you can come up with whole strategies. This YouTube video kind of covers some, but the other thing, when you get a bit more advanced, you can look at rebasing instead of merging. And those are two ways to kind of take different branches and put them together. I won't go into too much depth on them. And then there's a Git cheat sheet, which I included, which is pretty nice, because here's all the commands. Most of them I kind of just copy and pasted as I went along. So with that, I will leave you with a nice joke, and we can open it for any discussion, questions, things you thought were interesting, or was this all just one big waste of your time?
What's the worst thing that git push force can do? Just the absolute worst it can do.
You could delete all the files, git push force, and then your git commit history has somebody just deleting all the files, and everybody who pulls will have to revert back. That'd be a pain.
Okay.
But also, like this command I did, if I did recursively through every folder and I git push force all, I could remotely delete the entire Git history, which means there would be no way to revert back.
And that would mean the undoing of potentially millions of dollars worth of work.
Yeah, if they didn't have a backup.
Three lines of script.
Technically 2.
Oh god, this is horrifying.
Yeah.
Oh my god.
Yeah.
This is why we have offline backups of offline backups.
Easy way to get fired.
Yes.
Get potentially sued.
Yeah, you would get sued for all that you could possibly be sued for and then some. Because that would be, but I think a lot of the times you like physically just won't be able to get push force. Like they can, as far as I know, they should be able to turn it off. So
chances are that if you're in a position where you have the power to get push force or do anything of that nature, like that 3-line pile of hell, then chances are that you're going to be in a position where it was already expressly in your duties to not do that.
Yeah. Getting hired is kind of your duty to not get push force.
Well, it's probably also that you probably would have a vested interest not to do it. Like, aside from the legal repercussions, it's probably your work you're destroying anyway.
Yeah. Yeah, it is.
Oh, who has pride in their work nowadays?
Anybody who has a nice paycheck, which is a pretty good number of people. Yeah. I'm interested to hear if any of the freshmen who maybe haven't maybe your coding is limited and maybe this was over your head a little bit. I'm not sure. Okay, nice.
Yeah, that's me.
Did this make any sense? Some sense? Maybe it'll make more sense as you go along.
It was a good introduction, I think.
I think git push force is my favorite line now.
Oh boy. I was wondering whether or not I should include it for you. But
it's a good warning that saying
I
there's
never
a
knew
lot of power in this.
Yeah. I never knew a line of code could be so like intimidating.
Yeah.
Yeah. That's part of the thing is you should also know that you can do a lot of damage with your computer to your computer.
Oh yeah, the stuff my dad does.
Responsibility.
Yeah, like my dad controls for his job. He's controlling multiple computers on like his one computer. So, like someone at his job, I think accidentally he changed his setting on the wrong computer, and they just messed up a bunch of stuff.
Yeah. John, do you remember what the fork bomb command, like how you type it out?
I don't remember it offhand, but the basic idea is you create a function that calls itself twice asynchronously, and then you run that function.
Yeah. In terms of fork bomb bash. Yeah, this line of code.
I remember nothing other than that.
So
to make sure that you overload the stack, only the second one is actually called asynchronously.
Yeah, so what happens here, and you can write it like this, which is really confusing to look at, but
it makes you look like a magician.
It does. You're defining a program essentially, and that program just instantiates itself twice. And then it just keeps doing that. So it instantiates itself to make 2, and then those 2 will try and make 4, and you'll keep going like that until your system breaks. And that's one line of code. That'll break it. Yeah.
Or if not your system, then at least the thing that's running that script. Because last I recall, even the command line has a limited amount of system memory dedicated to it. So it'll stop itself eventually, but you might have a bit of a screwy situation and everything else.
Keyword eventually.
Yeah.
It depends on how fast your computer is. If it's something like this hunk of junk here, It's probably gonna take not even 2 minutes.
So.
But if it's say an Inspiron from 2005, it might be about 20 minutes before something goes terribly, terribly wrong. I have no idea. I've never done it on that one before. I think I'm going off a bit. My bad.
It's okay. Yeah, with great power comes great responsibility. So, yeah, I think that's it.
With great power comes Git push force.
Yes, it does. Yes, it does.
So is that everything you wanted to cover?
Yeah, I think so.
All right. Well, I think we should call it here. Does anyone have any more questions for Joey? All right, then. I think we can call it here. And everyone thank Joey for his time. I think it was a very informative presentation. And just so everyone is aware, this will be available online at another time. So you guys can check out our YouTube page to see the past meetings, and we will always post these to that.
Yeah.
I just wanted to thank you.
Yeah.
I appreciate it.
Awesome.
Thank you,
Thanks,
Joey.
guys.
Yeah, thanks.
Thanks.
Awesome.
Oh, what is your YouTube page?